Hey, time for another toy from Akihabara. It's another nondescript big blue box, but if I turn it up nice and close to the camera, so it's going to be hard to focus. Tektronix 2235 100 megahertz oscilloscope. This does work. I got it for about 4,500, 4,200-ish yen. That's about 40 bucks, 40 or 50 bucks. Yeah, it's just a standard 100 megahertz dual trace oscilloscope, and it works fine. Some of the switches are a bit sticky. They need some deoxide or whatever, but that's pretty much par for the course for old equipment. And it looks like someone's gone and put a multi-turn little knob on this this one here. I don't think that's standard, but that's cool because those knobs cost about $20 a pop, $15, $20 a pop. But yeah, someone wants a bit more precision on their dial. So let's open this thing up and see what's inside. Oh, it's a bit big for the bench, but that's all right. We'll get this thing open and see what's going on, because that's will be a bit more interesting than just looking at the blue top. Looks like we got a Torx, not a Torx, yeah. Whatever that's called. I've had this Torx-ish screwdriver here for quite a while, and I barely ever use it. So it's good that it's been able to justify itself. T10 is what I just used. I don't know if that's the right size or not, but it was close enough. Alright. Looks like we've got a couple more screws here and there. So I'll get this thing apart and I'll be back in a sec. Alright. I'll get this thing open. It's not going to come any more open than that. Ha! Oh, there we go. We're just a bit jammed. Alright, we've got a big yellow sticker there. What's that? Do not remove this shield while line core is connected to power. AC line potential and CRT circuit high voltage present under this shield. Ba 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 ba. Yep, I think I'll leave that on for now. Well, no, let's take it off. We haven't got the line cord connected. It'll just probably be PCB underneath there. What have we got? This hasn't been plugged in for quite some time. If I can get it off. Yeah, it's just PCB underneath there. Nothing too interesting. The thing works anyway, so I'm not going to do too much troubleshooting. So we'll take that off only if we need to. Alright, well, we want to see the top side. That's the interesting bit. Right, so I've got the top. This is the basically what we got in there. It's one main circuit board with a piggyback here for the inputs. We've got the board for the front controls, and we've got this little board that's got like a sticking up. It's not even, or it looks like it's meant to be held in, but it's not. It must have been dropped. There we go, put that back in. Yeah, it's just got like a little wire jumpers coming out. It is... don't know, it doesn't say. It just says Tektronix Incorporated. There's no real description of what that board actually is, but it's probably something to do with the controls, like the brains of the unit. So that's that there. It's got a whole bit of, what's that, 74LS0400. A bit of, you know, jelly bean logic and whatnot. CRT's in there, in this part here, with all these sorts of warning. CRT anode voltage 7,000 volts. Discharge CRT anode to chassis when disconnecting. Blah 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 blah. Instrument is manufactured under patents. High vacuum cathode ray tube is dangerous to handle. Basically, don't mess around with what you're not trained or not sure about. So I've got a bit of experience with CRT, but I'm still going to probably leave that alone just because I don't need to touch it, so not a problem. Here we got a delay line. It's just a coax wrapped around a certain length, probably a couple meters or something, and that's just to synchronize whatever has to be synchronized with processing and whatnot, because I know with CRTs, like for TVs and colour displays and black and white displays and that. When you're processing the luma and the chroma, that's for colour. Luma is the brightness and the chroma is the colour. The chroma takes longer to process than the luma, so you've got to actually put a delay line in to delay the chroma by a certain amount, and that way when it comes out the chip and goes through the rest of the circuitry into the CRT, it's all synchronized. Otherwise it's going to get out of synchronization and it just doesn't work. So that's probably a similar thing. I have seen that in a few CRTs. A few Crows. Some of them are longer, some of them are shorter, but yeah, just a pretty standard sort of thing. We've got the power supply under here, and it looks like they've got the high voltage gear going on in there too. How are we going to open that up? A couple of screws around the place. I might have to undo those screws and then come back. It's going to be a bit tedious to watch me do it. Down here we've got the like a piggyback board for the input sitting just here, and for the controls, like the vertical and horizontal controls. Looks like calibration stuff going on here. I have to see if I can find a service manual for this. I'm pretty sure I could find a service manual. I'm not really going to touch that unless I really have to, because I'm not even sure yet if I have the right equipment to test this thing, and it does work enough for my purposes anyway. And then we got the board sitting up here, and that's just the front panel controls. Hyper little pots, like nice little metal canned variable resistors, potentiometers, and switches and whatnot, so they'll get a good dose of deoxit. And same with this one here. That's the the time base control, heap of switches and stuff in there. I'm not sure how bad these capacitors are going to be, but they look a bit how you're doing. And see that one there. Looks a little bit discoloured, but I mean, it's a Tektronix Inc. 1 microfarad. 50 volt DC working voltage. So it's a 50 volt 1 microfarad Tektronix incorporated capacitor. I'll do some research on those, because if they're good and they don't have a problem, I might just leave them, because if I start replacing capacitors in certain areas, it might throw off the calibration, and then I'm going to have to play around with it. If I replace capacitors in the power supply, that's not going to throw off the calibration of the measurement side of things, because that's just putting out voltages. But down here, I'm going to be a little bit careful before you just go willy-nilly replacing stuff. Yeah, so I might do some research on that and see what the go is. So the next step, I guess, is to start figuring out how we're going to get the front panel off, and then we can start deoxitizing things. I might grab a service manual, like I said, and I'll have a look and see if I can find anything interesting to point out inside this thing. There might be some cool little bits and pieces here and there. So I'll be back in just one sec once I've got a bit more taken apart. Alright, got a parcel coming in the mail today from Digikey. These are all the capacitors, because I said I wasn't going to replace all the capacitors if I didn't have to, but I kind of changed my mind. I'm going to replace all the capacitors. All the electrolytics. That is, not the any ceramics or anything like that. So I think I've got a few other bits and pieces for some other stuff in here as well. But we have all of our electrolytic capacitors anyway. The old eco-friendly Digikey packaging. Reveal your goodness. Oh yeah. Alright, all Nichicon. KZE, what's that? KZN. I got like all the high ripple current rating ones. KMGs. Axial caps as well. I wonder what that one's for. 100 mic, 100 volt. Not sure. Big chunky one, 450 volt, 120 microfarad. That must be for this one. Because that is a... Ah, yes, that is. This capacitor is that big chunky input capacitor, the big main one. Apparently these are high quality, so that usually they don't need to be replaced. They're a Sprague brand. But you can't get this kind of base anymore, that three-way with the tab on it. They don't make them. No one makes that pattern. So there's two things you can do. You can either get a big cap, to replace it, and just kind of, those legs will line up with two of those holes, two of those 4 holes, and just stick it in and solder in. Or you could, I've seen people, they peel the little crimped over end here open, pull it out, gut it, put the cap in, and then solder it in, and then like re-crimp it with carefully with the pliers or whatever, and that will make that look original. But I don't really care about it looking original in this case. It's just a piece of Tektronix test equipment. If it was something like a valve radio or a valve amplifier that I want everything to look original and nice for the historic value, then I would do that. But it's just a scope, I picked up for $30, so I don't care too much. So I'm going to replace that as par for the course, along with all the rest of the capacitors, which you can see here. And we have our mains input capacitors. There's the one on the main board, and there's a smaller board at the back that has some small ones, 2 of them, those nasty Rifa ones that blow up and catch on fire. So that will be replaced. I bought I don't know what brand these are. I think these ones might be Vishay, very good brand. And these ones are, I will have to check because I'm not sure, but they are another very good brand. It doesn't say here, I can't remember. Anyway, I'll get the scope on the table and we will start having a look and start getting these capacitors pulled out and put back in again. So here we are. This is a board at the back. There's usually a black plastic cover over the top of this board here. If you can see that there, wires are a bit stiff, but it's got 2 Rifa caps. Wiggling my finger here, and then wiggling my finger here. They've got to be replaced. If you don't do any other replacements, replace those 2 Rifas there, and then the other big one is kind of underneath here. I think what I bought is actually too big. I'll see if I can fit it anyway. Anyway, I hope I didn't mess up too bad and buy something that was too big to fit, but that's alright. Also, there were some upgrades to the power supply section on these, depending on your serial number. I'm going to double check what I've got here because there was some improvements made to make it more reliable. So it was a few little jumper wires and just resistors and stuff you put in, and I think you replaced the MOSFET or something. I'll come to that later once I've figured it all out, and I'll let you know about that. Also, these capacitors around here, they should be changed as well because these dry out. These are the main output filter capacitors from the power supply, so they're filtering out all the ripple and keeping things nice and clean for the rest of the circuit. So if they're bad, you're going to get massive ripple injected into the rest of your circuit, and that's going to jam things up and cause all sorts of problems. So these want to be replaced, definitely, and those Rifas as well, because you don't want fires and you want the thing to work without too much ripple. So I'm going to replace everything though, because the silver little axial capacitors, which are around the place, which I can't find any right now because they're kind of small and hard to find. I've read that they are Panasonic brand, not Panasonic, not Toshiba, whatever brand, Philips. I think it's Philips brand maybe. They do dry out like normal electrolytics do. Over here you'll see some kind of axial looking devices, capacitors, just down here, and there's 2 of them here standing upright. 1, 2, there's 4 all up here, hiding around there. There's 1 underneath the shaft just here, there's 1 just there, and there's 2 just there. Don't touch those. They're not electrolytics, but they are a matched set. These 2 here are a matched pair, and these 2 are a matched pair. I'm not sure what the characteristics are that they're looking for to match, but if you change them, you're going to mess everything up. So those 4, don't touch them. Do not replace those. They don't have a problem with the drying out like electrolytics do. Coming back over here, there's no fan, which in some of these models they do have a fan. I'm going to put a fan in. There's a couple of components we've got to stick in down here somewhere, like a resistor, a diode, and something else. So that will go in, and then I'll solder the fan in there to give me some cooling inside this thing, because it does apparently get a little bit toasty, and a bit of airflow in there isn't going to hurt things at all. There's the 2, what are they? The tantalum capacitors, little blue things right at the end of my finger. 1 and 2. They might be a different colour in yours, but there's 2 little tantalums there. I'm going to replace those because tantalums can be very sensitive to overvoltage and whatnot. They tend to blow up, and when they die, if they don't catch on fire, they generally fail short, which can be very bad. That then ends up being the thing that usually catches them on fire because they short out, overheat, and blow up quite spectacularly. So I'm going to replace those just in case. I don't know what the history of this thing is, and the ones I'm putting in are going to be much higher rated. I think these are 25 volt, and I'm going to be putting in 50 volt from memory, 50 volt tantalums, just because I can. So I'll get to it. If I find anything interesting on the way while I'm replacing these capacitors, I'll let you know. But other than that, I think the next thing you will see me starting to do is around the power supply section here with that fan and any upgrades that are required here. Okay, so I've replaced the two small Rifa capacitors on this filter board here, and I did discover my confusion. I resolved my confusion with these big capacitors. It actually went there. So this green one was there. It's a 0.15 microfarad X-class 250 volt. Replaced it with slightly larger 0.15 microfarad 400 volt X-class. 440 volt, sorry, 440 volt. They were cheap enough, and it will fit there underneath the cover, wherever that is. There's a cover, so that cover goes on top. It will still fit in there because it's no higher than the transformer. And yeah, that's the big one there. So there's three you got to replace on here. This one, the two Rifas underneath, and then underneath the IC jack, just here, where my finger is, underneath the fuse holder and the IC jack, there's one more there just behind the power switch, which is that black box right down the bottom there. So that's the next one to do. I'll get back into it. Here's the old Rifas, which I pulled out. These ones aren't looking so bad right now. Hopefully that focuses. But they are starting to craze a little bit on the side. These can often be so bad they're cracked open, and what happens is because the epoxy or whatever they use there cracks open, the moisture and the humidity in the air gets in, they start to burn, and because they short out, and then it's just a cascade from there, and they end up catch on fire and burning up, and generally making a mess of things. So get rid of these Rifas and put some new ones in. So for this fan, we're looking at this part of the circuit board here in the power supply section. Just make sure you've let the everything discharge and it's all safe to go. Stick a multimeter here and there if you're unsure, and just make sure there's no deadly voltages. It's saying here danger 2 kilovolt DC present on this area of the board in a shaded area here. You don't want to be touching that when there's voltage there, because that will give you one hell of a kick and might lay you out on the floor for a while. And up here is the primary AC potential present on this area, which is this shaded area up here. So this is the dangerous part of the board. Make sure it's discharged. If you unplug it, leave the power switch on, unplug it, and that will help to discharge this quickly, and leave it for like a couple of hours or something, and then maybe just test a few capacitors here and there with the multimeter. Make sure that there's nothing going on here. This area here is where we got to play. In the 2235, there was no fan installed, and the components therefore weren't installed either. They're just kind of soldered over, so you got to suck the solder out on the pads, and then we're ready to stick the components in. So I'll zoom in on here and show you the detail. So we got the three components and the header. There's a capacitor here, capacitor C965. We got the diode here, CR965, and there's a resistor which is on my PCB is unmarked. It's just above the diode, and then our header goes here. So in the schematics, the capacitor is specified as a 270 microfarad 40 volt capacitor, electrolytic. I'm going to be using this one, which is a 63 volt at 330 microfarad. High voltage is not a problem. That's not going to cause any problems at all. It'd probably give this capacitor a bit longer lifetime because it's not so stressed. And the high capacitance in this application is fine. This capacitor is just a smoothing capacitor for the DC. It's being rectified for the fan, and this will smooth out any ripple and make the fan a bit happier. So that's no worries to go here. The positive side of the capacitor goes on the square pad at the top, and the negative on the circular pad at the bottom there. Over here with the diode, the CR965, it's these two pads here at the bottom. The line goes towards a square pad. I'm going to be using a UF4007. This is a kind of a high-speed diode. I don't know for 1N1004 or 1N1008 or the 1N100X series would work so well. I'm not sure, because this is a switch mode power supply, and we're working at high frequencies. I'm not sure what the frequencies for the 1N100 series diodes are, but just make sure you got something that's a relatively high frequency capability. It doesn't have to be too crazy, but you know, middle of the range. So the UF4007, they're an easy to get and high enough frequency diode, so I recommend that one anyway. And then the resistor here between these two pads is a 20 ohm quarter watt, just goes in there. And then our connector for the fan here. I'm not 100% sure which is positive and negative yet. I haven't had a close look at the schematics, but I'll probably just stick my multimeter on there in a second. I'll let you know which way that goes in once we've got it all together. I'll test it empirically to make sure I'm 100% correct before I let you guys know. So I'll go ahead and stick these components in, and I'll be back in a sec to see how it goes. Okay, so we're done. This is the top of the board now, of course. That there is our capacitor installed. There's our diode and our resistor, and there's our header. That's just like a standard 2.54mm, the standard sort of 0.1 inch header. The right hand side turns out is positive and the left is negative. If you have a different revision, there's some different board revisions depending on your serial number. It might be a slightly different positions. Just double check that to make sure what yours is, if it's a different position to this. But on mine, the right hand side is positive. It gives me about 9 volts DC. So for a 12 volt fan, it'll run it a little bit slower, which is no worries. It's a little bit quieter, and lower RPM means the fan's going to run longer. Those bearings will last a little bit longer than if it was running at full speed. So I've actually got these connectors now. I'll hold it in my hand. These ones are designed to slip onto those headers, and they use these pins. Where are we? Crimp these pins onto the fan cables. They slip into there, and that's going to plug straight on. All nice. That way I don't have to solder onto the board, and if in the future I need to do some servicing, I don't have to desolder the wires. I just unplug it, no worries. So I might put a little black dot down here next to the negative pin, just so that in the future I can make sure I get the fan plugged in the right way. With the modern computer fans, if you plug it backwards, they just don't work. So it's not such a big deal if you get it wrong way. Just unplug it or desolder it and spin the wires and put it back in. So that's the fan nearly done. Once we've got the rest of the unit working, we'll demonstrate it. Or I'll demonstrate it with the fans in place. Okie dokie, we have done all the capacitors. We've got the radials and axials around the place. So the blue ones down here are the axial capacitors. You might be able to see those on your screen, hiding down at the bottom PCB. We got some tantalums up here, which I replaced, up the voltage rating on those, and all the radial caps are the standard ones with the 2 pins, or the 2 legs coming out the same side. Just scattered around the place, and in the power supply, of course. So these ones here, I've upgraded them from 840 microfarads up to 1000 microfarads. You can do that on bulk power supply filtering, because you're just filtering out the ripple. So a bit more capacitance is a bit more better. Be careful about the rest of the circuit, because especially things like these axial capacitors, they're a value because they have to be a certain value very often. You can look at the schematics and see if they're power supply or if they're something else. If they're power supply filtering, you can generally be a bit loosey-goosey. You can go up, don't go down. Same with the voltage. Never go down voltages. You always go up if you're going to replace them. The same voltage or more, especially with the electrolytics, because they tend to pop. And tantalums are very, very sensitive to overvoltage. They'll short circuit and catch on fire. The big one over here, the 450 volt, I've gone from a 75 microfarad up to a 120. So that's, again, not a problem at all. And we replaced those Rifa X class and Y class capacitors that were in this case here, the filter board, and there's one underneath this this input filter, right underneath there behind the power switch. So that's all good. All the capacitors are perfect. I also fixed the power switch because it was a bit sticky, and so you turn it on and it wouldn't turn off. You had to manually pull the lever back out. So I put a bit of grease on the plastic moving bits, and that's come up really nice. And just generally clean the thing up. I've cleaned the front panel. It's a bit hard to show you. Maybe that'll focus. But yeah, that's come up really nice, taken off all the dust. One thing to be wary of though, on these scopes, don't use isopropyl alcohol on the volts division knobs. It tends to take the ink off the numbers. I don't know if you can notice that, but this one here is nice and dark. The numbers all the way around on that little plastic ring. This one is faded because I was wiping it with the iso alcohol and I was like, oh, there's a lot of dirt coming off. No, it's the numbers. So yeah, and these knobs are almost unobtainium. They're very, very, very hard to get. I'll also be careful of these knobs because they don't put too much sideways force on those because they will snap and you have to super glue them back on. There, I have personal experience with one of those knobs. This one over here. I accidentally bumped it and it snapped the little clips inside because they're very small clips and these are getting old, so a little bit more brittle than they used to be. But it's all together, so it's all going to be working okay. So next step, the fans. I was going to put this fan in, the X-Fan brand fan from Akihabara. It's just a sleeve bearing, just a fan, 12 volts. But I was on Digikey ordering some more parts, and I bought this one. This is a Sanace 60 Sanyo Denki. Denki is Japanese for electric, and Denshi is Japanese for electronic. So I'm a Denshi Gishi. Gishi is engineer, electric engineer, but I'm not really an engineer, but that's the word they use for an electrician, because I'm an electrician by trade. So Denshi Gishi, and Denki Gishi. So electric engineer, electronic engineer. That's your Japanese lesson for the day. Denki and Denshi. Denki electric, Denshi electronic. This fan is just the same. It's a 109R0612H402. So the 109R is the series. The 06 is a size, 60 mil. 12 is the voltage, it's 12 volt, and the H is for the like the blade profile, how much air it pushes, that sort of thing. So I've gone about 3 levels up from the most quiet, which is also the least air that's pushing. And I did that because I wanted it quiet, but it's going to run it slower than 12 volts. So I wanted to push a little bit of air. So I'm hoping I got a decent trade-off. So it's not too loud, but it will move a little bit of air through the case. It doesn't need to be blasting through like a computer server at full tilt, but just a little bit of air movement, just so it's not like hot air stagnating in there and just getting warmer and warmer. Just a little bit of air movement will keep that nice and cool. So that'll go in once I buy some or obtain some longer screws, because the screws I had for this obviously aren't going to fit because the Sanace is bigger. But we'll get to that, and that's not a big problem at all. So we'll keep that out of the way anyway while we're working inside. The next step is to do a few little upgrades. There's a few things, because this is a slightly earlier unit, there's a few things that have been revised and upgraded, and also there's a few things that should be replaced because we've got better components these days since 30 years ago. One of those is down here. I'll zoom in a bit and hopefully it's not too dark. Okay, yeah, you can see right in the middle of the screen there's some little brown resistors. I'll get my pointer so my big fat fingers aren't in the way. Just here. This is the focus control pot. And these 4 resistors, and there's 2 just up here, they're carbon composite resistors. Now, back in the day, these were alright because that's what they had for their technology of the day for this application. But nowadays, these can fail, and they can fail short circuit or fail open circuit or whatever random position they decide to fail in, and it will mess up all your focus. So what I've bought is I have gone and got, I'll dig them out, I've got them right next to me here. Here we go. 510K. These are 510K, half watts. There's 6 of them there that should be replaced. I believe it's 6. There's a few, 1 or 2 others that I'll replace as well. But these are metal composite resistors. They are HVR series by Vishay. These are good for like 2 or 3. I'll move that label into view so you can see it. These are good for like 2,000 or 3,000 volts across the resistor. And for the focus circuit, you need a high-ish voltage rating. That's why they got a whole heap of them strung in series. There's 4 of them there to up the voltage rating for that circuit to make sure there's no flashover or whatever. So I'm going to replace them with metal film, which are a lot more reliable than the old carbon composite, and that will stop this from becoming faulty. At the moment mine isn't, but it is a common fault where these will go open or close circuit and mess up your focus. So if you have one of these and the focus doesn't work right, it's always out of focus and you can't dial it in, check this area of the circuit and replace those resistors. So we're going to do that. Also, there's a few other upgrades to do in the power supply section, replacing some MOSFETs, and I've got here, where were they? Yeah, got these, what's that? That's a SCR to upgrade. NPN transistor, 6 amp. I think that one's going to replace the one that's sitting on the heatsink just here. And there's another one somewhere. N-channel MOSFET. So we're going to replace those because they've done the upgrades and they found that with this design, the early design, if one of the parts fails, it tends to take out like 5 or 6 other parts down the chain. Which is no good because you end up with not just one part to replace but a whole bunch. And also there's a few resistors to replace and some jumpers to do, so that if the power supply fails, it'll shut down rather than keep going and burn itself to pieces. That's one of the upgrades I did. Also, we have some upgraded MOVs, a varistor, to go in as well. So yeah, I'll work out exactly what I'm going to do there. I'll do it. We'll be coming back and I'll explain exactly what you have to do to do the same thing. I haven't gone right through yet, but I will in a sec and see what's involved. So give me one more second, YouTube time, and I'll be back with a full description of how to upgrade the power supply. And we are done. All the mods are finished. So right in the middle there, I'll zoom out a bit so we can focus. You see those blue resistors? These ones here, and these two just down here. They've been replaced. They're the old carbon composite style, looking like that. Now they're metal films, and I've spaced some of them off the board. I've like kind of gone up, down, just to give a bit of space for some airflow around there, and keep those a bit cooler. Then if we move over here, there's a whole bunch of stuff inside here. I've replaced the parts on here. There's a transistor and some a MOSFET and some transistors, and then over here there's an SCR right down the corner there. If I can get it into the shot, just there. Replace that. I've added this Diode-Resistor network, as they call it, and a few other things. I've removed a resistor and put that jumper wire. It's a bit hard to get in. There it is. So I put that jumper wire in, and there's a few other resistors that you've got to replace to get the thing working. And we're pretty much done. So now it comes down to plugging it in, seeing if it turns on. Oh, and seeing if the fan runs. On the schematic it says to put a 20 ohm resistor there. I've put a 10 ohm instead because I just wanted the fan to run a bit faster. Yeah, that 20 ohm is designed for the Tektronix fan, but I've got a different fan, so I've played around with that, hoping to get a little bit more airflow than the anemic slow spinning that the other X fan was. What was it? X fan. The other X fan was spinning at. So I'll try that, and we'll see if we get smoke or if we get a trace on the screen. So let's see what happens. Okay, so going handheld now. I'm going to be using the mic on the cam, so it's not going to sound quite as good, but we'll make it through. Basically, I've got the signal generator here. Got the wires coming down, all the way down into the front panel here, and we're ready to turn the thing on and see what happens. So if I press the button, we should hear a little whoop as the power supply comes on. There it goes. And give it a second and we might see a trace. I'll have to tweak the settings, I think. So if we there we go, we're getting something on there. I'll focus that in. Oh yeah, look at that. That is nice. I'll bring the intensity down just a bit, just so it's nice and sharp. Yes, we got no smoke and it's still working. Oh yeah, that's working quite well. That instability is the not the scope, that's the function generator. At that, here's a thumbs up. Alright, so I'm going to put the thing back together, put all the shields back in, put the case back on, and I think we've got a winner. Winner, chicken dinner. Got to test that fan. Alright, I'll do that next. I'll forgot to put that in, so I'll put that in and we'll see how fast that spins. Okay, fan is installed. Let's see what happens when we turn it on. Not too bad. A little bit of fan noise. I mean, I could have gone for a quieter fan, but it would be less airflow then. So I can live with that sort of noise. That's all good. Alright, I'll put the case back on and see what it looks like when it's done. Hey, look what I've got. A replacement knob. These things are really hard to find, but two of them popped up on eBay. One went real quick and I got the second one. It's got all the numbers nice and dark there, not all faded and wiped off like the one on the scope. So let's install this. Let's replace that old faded one. So I've got the got the scope here. And this is going to be interesting to try and fit. I'll zoom out a bit. About there will do. So I'm not sure I'm going to be able to show this. Well, I'll show the old knob just for a recap. It's that one there. It's going to look like that because I have the new knob here. It's actually really easy to replace this knob, a lot easier than I thought. These little red calibration knobs, I've got just a grub screw on the side there at the end of my finger, and then you take that off and this one just slides out. I'll just double check I got it in the, yep, I got it in the right way to pull out. The new one goes in that way. That should be the number 0.5, I think it was. Lining up. I'll make sure it's the same. Yep, it's the same as the other side. And then this one, I want to make sure that that is going to line up too. So I'll just tighten a little bit. Right there, like that. No, hang on. Around a little bit more. Like that. Look at that. Beautiful. Oh, also, some of you who know about these scopes will have probably been screaming at me since the start. I said that I thought this must have been a retrofit. It's not. This knob is actually from factory. It's for to allow you to use a vernier scale on here to make measurements on the screen. You can turn it by very precise amounts and see the change on the screen. And for measuring stuff, before they had the like digital scopes and all that sort of gear with the on-screen measurement and that sort of jazz. So that is done. We are complete. So I'll plug it in. I'll probably go handheld again with the camera so we can see the screen a lot easier from the front. And yeah, let's see what it does. It looks like we're done. Absolutely complete. We've got the cover on, so there's no turning back. We've got the new knob on the front there. This one here, looking pretty smick. We've got the new fan in the back. We've got the capacitor replaced. The power supply's upgraded. Those resistors in the middle are done. It's all been polished and finished off. And we're ready to do a power on test. So we've got the cable here into the input coming from the function generator. We've got the function generator functioning, we've got the Nixies nixing, flux capacitor is fluxing, and we are ready to power on. Power supply is powered up, fan is on, and we're getting a trace. Look at that. Beautiful. Nice and sharp. Not a problem at all. So if we alter the frequency a bit, looking pretty good. If I move this, you might see some glitching. That's the function generator. It's just the oscillator settling down as I twiddle the knob. It freaks out a bit and then settles down. Sometimes it does it. That's not the oscilloscope at all. But that is looking good. I'm going to give that an enthusiastic thumbs up. And that's pretty much the end of the video. We're done. We're finished. We made it through. So if you're looking for any information on what I did for this, there's a few, like the transistors and stuff in the MOSFET. They were Tektronix branded, or Tektronix part numbers, so I've actually cross-referenced those to modern parts. Other bits and pieces, you'll find the information in the description below, and some links to some service bulletins and other PDFs and other information there, so you can find that and follow along. That's pretty much it then. Alright, so don't forget the Patreon. If you're thinking about that subscribe button, go ahead and give it a click, and as always, keep it safe, and we'll see you next time.